In this video, I'll show you a couple of examples of how we multiply and divide power series. Generally, you're just going to multiply and divide power series the same way you multiply and divide polynomials. If you can multiply polynomials, you can multiply power series. So let's say somebody asked you to do this. Let's say you had x squared minus 2x, and you're multiplying by x cubed plus 4x squared minus 7x plus 2. Well, the way you would do that is you'd say, I've got this polynomial with 4 terms, and I've got a binomial over here, polynomial with 2 terms. And all you would do is you'd take the first term of this polynomial and you multiply it by all of the terms over there. And then you'll take the second term of this polynomial and multiply it by all of the terms over there. So we'll have x squared times this entire polynomial. It's called distribution. And then we'll have minus 2x times that entire polynomial. And then we'll distribute the x squared. We're adding the exponents. X squared times x cubed is x to the 5th. Bring the coefficient down. X squared times x squared is x to the 4th. Bring the 7 down. X squared times x to the 1st. Add the exponents. That's x cubed. And then 2 times x squared is 2x squared. Then you distribute the 2 to all of these guys as well, or the 2x. So I have negative 2x times x cubed. Add the exponents. That will give me an x to the 4th. Negative 2x times 4x squared. I'll multiply the coefficients first. I get negative 8x, or excuse me, negative 8. And x to the 1st times x squared is x cubed. Multiply the coefficients first. Negative 2 times negative 7 is positive 14. X times x is x squared. And then last times last is negative 2x times 2, that's negative 4x. Now, after you've distributed, then what do? I hope you all said collect like terms. That's exactly what we do. We get all the x's together. Usually we start with the highest power of x. The highest power of x on this list is x to the 5th. So we've got that right there. Then I add all the x to the 4th terms. So I've got a 4x to the 4th and a negative 2x to the 4th, and I think that's it. So 4 minus 2 times x to the 4th, which is, of course, just 2x to the 4th. Then we group the x cubed terms together. Got a negative 7x cubed minus 8x cubed. So that's negative 15x cubed. Then we group the x squared terms together. 2x squared and 14x squared is 16x squared. And then last times, or I'm saying last times last, and then the last term is just this x term, negative 4x. So we'd be done. That's how you multiply polynomials. Well, let's look at this now. What do you do with something like this? Now, you're going to do pretty much the same thing. The only problem is, now you've got infinitely many terms. So I've got infinitely many terms over here and infinitely many terms over here, and I want to multiply them together. So it's going to be very difficult to come up with an expression, a single series, representing this product. So instead of doing that, all I'm going to ask you to do is find the first 4 non-zero terms of the product of the series shown below. So if our series looks like this at the beginning, I would just say this plus this plus this plus this plus ... and those ... would represent all the rest of the terms of my series. So that's the plan. It's just like multiplication. There's just one little tweak. It's like multiplication of polynomials. There's one little tweak that we have to keep in mind if we want the first 4 non-zero terms of the product. Let's do this. The best way to start is to write out this series and write out that series. So that first series, when n equals 0, we get 1. When n equals 1, we get negative 2x. When n equals 2, that's negative 2x, quantity squared. That'll be 4x squared over 2 factorial. When n equals 3. This is, you should write it down. This is n equals 0. Here's n equals 1. Here's n equals 2. Let's do n equals 3. That's going to be a negative 2 cubed is negative 8 times x cubed over 3 factorial. When n equals 4, what do we get? Negative 2 to the 4th is 16. In the denominator, we've got 4 factorial. And then let's just go all the way up to n equals, well, actually I've got 5 terms right there. Let's go up to n equals 5 just in case we need it. We'll talk about whether or not we're going to need it in a minute. When n equals 5, we'll have negative 2 to the 5th, which is negative 32, times x to the 5th over 5 factorial, plus higher degree terms. So that's one of our polynomials, or excuse me, one of our series. And we're multiplying that by this guy. When n equals 0, we get 1. When n equals 1, well, that's a negative 1 to the 1st. It's alternating, so it went from positive 1 to negative 1. If n is 1, we get x cubed over 3 factorial. And we've seen this series before. It's all those exponents are odd. The denominators are that same number that you have in the exponent, but factorial. So I think we're going to get x to the 5th over 5 factorial, x to the 7th over 7 factorial, plus higher degree terms. And if you're not sure, plug in n equals 2 there. What do you get? 2 times 2 is 4, plus 1 is 5. That's right. When n equals 3, what do you get? Negative 1 cubed is a negative. Good. If n is 3, 2 times 3 is 6, plus 1 is 7. So this is right. So I've got this times this, and I want to multiply them, and I want to find the first 4 non-zero terms of this product. Okay. Well, in order to do that, I need to think about what will happen when I multiply these guys together. Well, the lowest degree term I will get is that 1 times 1. So I think I need to keep the x to the 0 term when I multiply these. So the 1 times 1 is going to give me a 1. That'll be one of my first 4 non-zero terms. Then maybe the x to the first term, x squared, x cubed terms. If all 4 of those are non-zero, that would be my first 4 non-zero terms, the x to the 0, x to the 1, x squared, and x cubed terms. But it's possible that because of these pluses and minuses, because of these signs, it's possible that we might get, whenever we add like terms like this, we might have something like 4 minus 4 times x to the 4th, and we get 0x to the 4th, and so the term disappears. So that can't be one of our non-zero terms if it's a 0 term. So we want to keep a couple of extra terms. I would recommend keeping at least 1, possibly 2 extra terms. We need 4 terms. I'm just going to guess up to x to the 5th. I'm going to play it safe. And I'm going to save all of the terms up to x to the 5th. Anything that I know will be x to the 6th or higher, I'll just write plus dots for that, because it's going to be part of the rest of the series that we're not going to write down. Probably part of, yeah. We just want the first 4 non-zero terms, and the x to the 6th terms and higher are probably part of those little dots at the end of the series. Okay, those dots that are representing the end of the series. So we're going to keep all the terms up to x to the 5th. Now, to do this multiplication, I'm just going to get rid of that. I don't want to look at that anymore. Okay. We're just going to distribute. First we'll have 1, this 1 times all of that. And I want to keep everything up to x to the 5th. That's the plan. So I'll have 1 times 1 minus x cubed over 3 factorial, which we know is 6. And then I've got x to the 5th over 5 factorial. What's 5 factorial? 2 times 3 times 4 times 5, 120. Minus higher degree terms that we're not keeping. Okay, so that's our first part. And we're distributing. So we're distributing all of this times all of that, and we're just going to go term by term, and we're trying to keep every term that would lead to an x to the 0, x to the first, x squared, x cubed, x to the fourth, or x to the fifth, because we want the first 4 non-zero terms. If those are non-zero, those are it. Okay, so we did 1 times all of this. That's done. Now we want negative 2x times all of that. And negative 2x times 1 will give me a negative 2x, so I'll keep that. Negative 2x times x cubed over 6, that'll give me an x to the fourth, so I'll keep that. But negative 2x times x to the fifth is going to give me an x to the sixth times something. And we don't want to keep any x to the sixes. We're only going up to x to the fifth. So we'll just put plus dots, representing the rest. Then the next one I need is this 4x squared over 2 factorial, which simplifies to 2x squared, times all of this. Again, keeping only the terms that will multiply to give me an x to the fifth or lower. 2x squared times 1 is going to give me an x squared term. 2x squared times x cubed over 6 will give me an x to the fifth term. 2x squared times the x to the fifth would give me an x to the seventh term, so I don't need that. So I've got that there. Then I want the x cubed term here, so I've got negative 8 over 3 times 2, so that's negative 4 over 3 times x cubed. That's what that simplifies to. Times all of this, and you only want to keep terms that will lead to an x to the fifth or lower. This times 1, of course, is x cubed, but this x cubed times that x cubed will give me an x to the sixth. I don't need it, so just put plus dots. Then here, I've got 16 x to the fourth over 4 factorial. 16 over 4 is 4. Well, actually, I'll just write it out like this. We got 16 is 4 times 4. I've got 4 times 3 times 2 down here, times x to the fourth. The 4's reduce. 2 goes into 4 twice. Okay. And we're taking that and multiplying by this. So that's just a 1, and then x to the fourth times x cubed would be x to the seventh. Okay. Then x to the fifth, I need that because that's an x to the fifth term. That times 1. It's 5 times 4 times 3 times 2. 8 goes into 32 4 times x to the fifth. And x to the fifth times 1 gives me an x to the fifth term, but x to the fifth times x cubed would give me an x to the eighth term, so I don't need that. All right, so this is the series. This is the product of those two series. And these dots represent all the terms that are x to the sixth power or higher degree terms. So we just want to distribute now, and then we'll collect like terms. See, you can do this. If you can multiply polynomials, you can do this. You just have to remember that you're keeping some of the terms, and the number of terms you keep depends on what this says. It says find the first 4 non-zero terms. I had to find the degree of the lowest term, which was a constant, so that's x to the 0. And then I go up to the fourth one because I need 4 non-zero terms. And then I kept a couple of extra terms just in case any of those had 0 coefficients. So now we're just multiplying. 1 times that is just that. And then we distribute the negative 2 over here, negative 2x. Negative 2x times 1 is negative 2x. Negative 2x times negative x cubed over 6, that's positive x to the fourth, And 2 over 6 reduces to 1/3. And then we do 2x squared times these guys. X squared times x cubed is x to the 5th. And 2 over 6 is going to give me a 1/3. And that's itself times 1, so we just write it down. And then we've got this times 1, so that just reduced to 2 over 3 times x to the 4th. And then over here we've got minus 4 over 15 times x to the 5th. And all of this is plus higher degree terms. Okay, now you want to collect like terms, and this is different from multiplying polynomials. We start with the lowest power of x first. So I've got 1 here, so that one's taken care of. And then I want any x terms that I have. I only have one of them, so it's negative 2x. And then I want the x squared terms. Do I have more than one of those? No, I just have a single x squared term, so 2x squared. And now I need x cubed terms. So I've got a negative 1/6 x cubed minus 4/3, so that's minus 8/6 x cubed. Okay, those aren't going to reduce, so we're done. We could just put plus dots here, but since I did go to the trouble of finding these other terms, I think I'll find them as well. For x to the 4th, I've got a plus 1/3 x to the 4th, and plus 2/3. 1/3 plus 2/3 is 3/3, so that's 1 x to the 4th. And then for the x to the 5th term, we've got a 1 over 120 times x to the 5th, minus 1/3 times x to the 5th, minus 4 over 15 times x to the 5th. And you keep going. Okay. So that is our answer. It's just not simplified. So let's go to the next page and simplify. So we've got 1 minus 2x plus 2x squared. That's minus 9 over 6. So it's negative 3 times 3 over 3 times 2. So it's going to be negative 3 over 2 times x cubed plus x to the 4th. And then that arithmetic is not something I'm going to try to do in my head. We'll just do 1 over 120 minus 1/3 on the calculator, minus 4 over 15, hoping they give us an exact answer. It's always nice. We get negative 71 over 120. X to the 5th. And this is the same. This is the first 5 non-zero terms of this product. Now, once we learn about Taylor and Maclaurin series, you'll see that these are actually Maclaurin series for a couple of known functions. Now I'm just telling you what's coming. This turns out to be a Maclaurin series for e to the negative 2x, and this turns out to be a Maclaurin series for sine of x. So we just found the first 6 non-zero terms of this function. Like if I want to represent this function as a power series, this function can be written this way as a power series centered at x equals 0. So that's the Maclaurin series for this product. Okay, now I'm not going to prove convergence or divergence here, but this product converges on the intersection of the interval of convergence of this one and the interval of convergence of this one. This series converges for all real numbers, and it actually happens to converge exactly to this function, e to the negative 2x. And this one converges to sine of x. So the product will converge on where the entire line of real numbers and the whole real line of real numbers overlap, which is of course the entire real line. So this product converges to this, or this infinite series converges to this product for all real numbers as well. Okay, so let's recap the process for multiplying power series. It's just like multiplying polynomials. You expand this guy and expand this guy, and then you distribute like we did over here. You take one term at a time. You say 1 times all of this minus 2x times all of that plus this term times all of that, and you're just distributing to the entire series, but you don't want the whole thing. You're going to be here all day if you do that. Be here indefinitely because we have infinitely many terms. So since they ask us for the first 4 non-zero terms, we'll find the first, 4, 5, 6 non-zero terms. I recommend at least doing 5 non-zero terms all the way up to x to the 4th. And we're taking extra terms just in case some of these sums at the end when we're collecting like terms, just in case some of them happen to be 0. Because if it's 0 and you only saved 4 terms, and I've got 3 non-zero terms, you needed 4 non-zero terms, you'd have to start all over again. So that's how we multiply power series. And I think I'm going to save dividing power series for the next video.